Hello guys, don't forget to put your name on your paper before you take a picture to turn it in to Google Classroom. Okay, you may still turn it into the sub, but turn it into the Google Classroom first. That is where I will be looking for it. This is called balancing equations. Now, anytime you have a reaction, you have a reactant side, as you should have already seen on your notes. And you have a product side. By the way, those notes go on page 28, I believe, in your INB notebook. Yes, page 28. Okay, now, most of the time you get a word equation. You have to do the chemical naming. Now, I think we should still practice a little bit on the chemical naming, so I went ahead and did the chemical naming part for you. Okay, let's go ahead and go to the next page so I can give you an idea of what you're going to do. Okay, every time you have a reaction, that yield sign, it's kind of like an equal sign. Whatever you have in your reactants, you must have in your products. Okay, so for that first chemical formula, you have copper, you have oxygen gas, you have copper 2 oxide. Now, the trick here with balancing is you have to know what you have. Let's go ahead and erase that and use a different color, just so you can see it a little better. Okay, you have copper, you have oxygen. On this side, I have only 1 oxygen. On the product side, I have 2 oxygen. Now remember that that bottom number tells you how many of that particular atom you have. So on the reactant side, I have 2 oxygen, and on the product side, I have 1 oxygen. Now, are they equal? No. So, what can you do to make it equal? You can put a coefficient. The only place you can put a number in a chemical reaction is the front. You can't put anything in the middle. Okay? All right, so if we have 2 coppers on this side, on the product side. So let's go ahead and put a 2 on the reactant side. That makes my 1 into 2. Is it equal now? Yes. Now, is oxygen equal? Nope. So I need to put a 2 here in front. I can only put a coefficient in front. I can't just make the oxygen a 2. It comes together. Remember that this whole thing is a compound. So when you affect one, you affect the other. So I have 2 oxygen, yes, and now that's equal. But now 2 times 2, I have a total of 4 coppers on the product side. So does that change my copper on the reactant side? Yes, it does. So we're going to erase that 2, and we're going to make it a 4, because 4 times 1 is 4. Now I have 4 coppers. So are both sides equal? Yes. Okay, now how do the coefficients work? Anytime you don't use a number in one of them, that means you automatically have a 1. So for this particular compound, my coefficients, the stylus. Okay, my coefficients are 4, 1, and 2. This is your answer. Now, you still have to look at those coefficients. Can I reduce? No, I cannot reduce. So that's my answer, my full, complete answer. Okay? If you think you're doing okay, go ahead and give it a try. I'm going to go ahead and do number 2. Okay, so anytime during this video, I'm going to go ahead and walk it through. Since I'm absent today, we're going to do it together. You have hydrogen, actually this is hydrobromic acid. You have magnesium. And you have magnesium bromide. Okay. You also have hydrogen gas. Okay, now don't forget you are going to be tested on all of the material that you have these 3 days on Tuesday. So make sure that you're following through and that you understand what's going on, okay? Make sure that you have those notes. You will be allowed to use the notes during the test. Okay, so here we go again. I have my reactant side and I have my product side. So how many hydrogen do I have? Just one. How many bromine do I have? Just one. And how many magnesium do I have? I have one. Okay, so now let's look at the product side. I have one magnesium, I have two bromine, and I have two hydrogen. Okay, magnesium is equal for now, so let's go ahead and leave that alone, and let's try bromine. I have two on my product side. So what do I need here? Remember, the only place you can put a number is in front of the compound. Since bromine does not have a number, that means you only have one. So 1 times what would give me 2? That's right, it's a 2. This multiplies into everything in that compound. So I have 2 bromine, and that also gives me 2 hydrogen, because this number will affect everything you have here inside the compound. All right, now is everything equal? Yes. So what happens when you don't have to do anything in front of the other compounds? Remember that they are all ones. So what are my coefficients? I have a 2, 1, 1, 1. This is your answer. Okay, before you go to the next frame to do the next equation, see if you can do it by yourself. And then you can double check with the next part that I'm going to do. Here's number 3. Did you already do yours? Did you already try to do it by yourself? Just to see if you can do it? Okay, now this is a combustion reaction. It's going to be releasing energy anytime something burns, like a match. It's a combustion reaction, okay? And I do have an example of that in tomorrow's video for law of conservation of mass. Because this balanced equation means you can't create mass, you can't destroy it, you're just manipulating it. So when something reacts, you still have everything the same, you're just going to have different types of compounds on the other side. You still are going to have the same amount of mass. You're just going to have, instead of having a methane gas, you're going to have a carbon dioxide. Instead of having oxygen gas, you're going to have water. So your products change. There's an actual reaction there. Okay, so first step is this is called the tally method. You have carbon, you have hydrogen, and you have oxygen. Okay, how many carbons do I have? I have 1. How many hydrogens do I have? I have 4. How many oxygens do I have? I have 2. Now let's look at the product side. I have 1 carbon. Now this is a little different. I have 2 oxygens on each compound. I have 2 over here, and I have 1 over here. So anytime you have a plus in between, 2 plus 1 gives me 3 total oxygens. Okay. All right, now I have 2 hydrogen. Little trick. Balancing equations is a trial and error. Remember that you can always go back and forth and erase your coefficients, okay? If you get confused, look at the first number. If you started with a 1, erase everything and start with a 2. If you're still confused, erase everything and use a 3 and see if that works out, okay? Little trick. When you have something that splits, like this, where you have 2 oxygens on the same side, on the product side, let's do that last. Okay, so here I have 1 carbon. I have 1 carbon, so that's equal. Here I have 2 hydrogen, and over here I have 4 hydrogen. So 2 times what will give me 4? If I put a 2 here, remember the coefficient multiplies to everything in the compound. So not only does it give me 4 hydrogen, 2 times 1 is going to give me 2. So now 2 plus the other 2 gives me a total of 4. Let's do that again. Let me erase this just in case you didn't understand. Okay? And just because I'm not there for you to ask me questions. Remember that here you only have 1 oxygen. And here you have 2. So earlier we had 3 total on the product side. But by putting this 2 in front, it gives me 2 oxygen now. So this 2 plus this other 2, now I have 4 oxygen on this side. Okay? So everything's equal except for the oxygen. So you're going to go back to the reactant side. 2 times what will give me 4? That's right, a 2. 2 times 2 gives you 4. Now is everything equal? Yes. So now what are my coefficients? Remember, if we didn't do anything, it's a what? It's a 1. 1, 2, 1, 2. I know you guys are getting this because you guys are smart. Okay, now, one little thing. If you can ever reduce the coefficients, all of them, then you must reduce. Just like when we did the chemical crisscrossing. If you can reduce, you have. Okay, make sure you do number 4 by yourself and see if you can do that without me. And that way you can double check yourself. You have sodium iodine plus lead nitrate. And you have Roman numeral 2 nitrate. Then you have sodium nitrate. And then you have lead iodine. Oh, that barely fits. Okay, let me put the little 2 over here. Okay, so now remember, make your little list. Now sometimes when you have, let's go ahead and make a list of what we have. We have sodium, we have iodine, we have lead. Now look at this. When you have a polyatomic ion, this right here is a polyatomic ion. If you have it on the reactant side and on the product side, you have the same polyatomic ion. Remember that NO3 is nitrate. It will save you a lot of headaches if you put the polyatomic ion together. Okay? That's only if you have it on both sides. Okay? If you have NO3 on one side, but you have something else on the other side, like an NO or NO2, you have to separate it. The N is by itself and the O is by itself. Okay, but when you have a polyatomic ion, this can save you a lot of time. So most of the time, I like to start with a polyatomic ion. But let's go ahead and start with what we have. Sodium, we have 1. Sodium, we have 1. Iodine, we have 1. And over here, iodine, we have 2. Here we have lead. We have 1 lead. And over here we have 1 lead. Now, how many NO3s do we have? That number on the outside tells you how many total of that compound you have. Here you don't have parentheses, and that's because you only have 1 NO3. Okay, most of the time when I have a polyatomic ion, I like to start with that. But remember, you can start anywhere. If it doesn't work out, you can easily erase and then just redo the coefficients. Okay? All right, so let's start with the NO3s. I have 2 on this side, and I only have 1 on this side. So 1 times what will give me that 2? We can put a 2 right there. And so that changes this to a 2. But remember, when you change that nitrate, that coefficient also changes the sodium. So this sodium will be 2. Okay? All right, so let's go to the other sodium. 1 times what will give me 2. 2. So that gives me 2 sodiums. Remember, this changed the sodium, but it also affects your iodide. So 1 times 2 gives me 2. Now, are all of these equal? Yes, and it's following the law of conservation of mass. So what are my coefficients? Don't forget, whenever you don't have to put a number, it's going to be a 1. So your coefficients are 2, 1, 2, 1. Let's say we had gotten a 4, 2, 4, 2. Whoops. There we go. If you have numbers that can reduce, you must reduce. All of these can be reduced by 2, so 4 divided by 2 gives me that 2. 2 divided by 2 gives me that 1. 4 divided by 2 gives me that 2. And 2 divided by 1 gives me that 1. This must be your actual answer, your coefficients. So make sure once you have your coefficients that you look at all of them. You have to be able to reduce all of them, not just a couple of numbers, for it to be right. Okay? All right, let's go ahead and do number 5. Now, if you're already okay, and you don't need my help, go ahead and do the last couple of equations all by yourself. You have aluminum chloride plus ammonium. What was that? Hydroxide. And then you have aluminum hydroxide. And I ran out of space, so let's write that down here. And then you have ammonium. What was that? Chloride. Let's squeeze that in right there. Okay. So what are my chemicals? I have aluminum. I have chlorine. I have ammonium. Now we need to double check. This is a polyatomic ion. Do I have the same polyatomic ion? Yes, so we can leave it together. Now OH is a hydroxide group. That's a polyatomic ion. Do I have the same polyatomic ion on the other side? Yes, I have the OH right here. So we're going to put that together. This will save you time in bigger equations. Okay, so on this side, I have 1 aluminum. And on the reactant side, I have 1 aluminum. On the product side. On the reactant side, I have 3 chlorine. And on the product side, I have 1 chlorine. On the reactant side, I have 1 ammonium. And I also have 1 on the product side. On the reactant side, I have 1 hydrogen. But here I have 3 hydroxide. So that goes here. All right. So now here we go. You can start off with a polyatomic ion, or you can start off with an element, whichever way you want to begin. Okay? Usually I start off with the polyatomic ions just to make it a little easier, and everything else will fall into place. So NH4, it's already equal. So let's go to hydroxide. Here I have 3. So 3 times 1 is 3. Let's see if we can make this other side. 1 times what will give me 3? You have to put a 3 in there. That's my coefficient. This makes my hydroxide 3, and now it's equal. But don't forget, it not only affects hydroxide, it also affects ammonia. So that means now I have 3 ammonium. Okay, so let's go to the product side. Here I only have 1 ammonium. So let's change that to a 1 times 3 is a 3. Now it's equal. There's my form. Okay. Now that also changes my chlorine. So now I have 3 chlorine. which is a good thing because now it makes this equal. So now is every single part equal? Yes. So my coefficients, remember if you don't write anything in there, it's going to be a 1. My coefficients are 1, 3, 1, 3. And this you cannot reduce. So that's my last answer. Okay. Oh wait, we have one more question. We have number 6. Okay. Just in case you're still not on your own, let's go ahead and do that one too. NaOH gives you sulfuric acid and sulfuric acid. It's going to react together to give you sodium sulfate. And let's go ahead and add water. Okay. So now on the reactant side, I have sodium. Now OH is a polyatomic ion. But do I have it on my product side? Nope. I have oxygens, I have hydrogens, but I do not have it. So I cannot use it together. Oxygen has to go separate, and so does hydrogen. Oh, I like this one. Now I have hydrogen here that's already added. And here I have sulfate, another polyatomic ion. However, is this polyatomic ion on the product side? Yes, it is. I would put it together if I was you. You can separate it, but it's going to take longer to figure out. Because if you separate the oxygen and the sulfur, you're trying to balance them out in the same place. So this oxygen is going to be separate from that oxygen. Okay? Here I only have one sulfate, and I have one oxygen. For sodium I have 2, and for hydrogen I have 2. Okay? All right, so now let's go to the reactant side. For sodium I have 1. For oxygen I have 1. For hydrogen, here I have 2 and a 1. So 2 plus 1. Remember, there's a plus in the middle. You have to add them. So I have a total of 3 hydrogens. That already tells me I'm going to have to multiply those two and get a common denominator. Sulfate over here, I only have 1. So I have 1 sulfate. Okay, let's equal this out. Now the polyatomic ions already equal, so let's figure something else out. 2 times something cannot give me 3. So let's find a common denominator. Let's use 6. Or you know what? Let's do something bigger. Like 12. Never be afraid to go bigger. I just want to try something, see if you can see it. 2 times 12 is 24. That gives me 12 oxygens. Okay, I'm going to show you how this is not going to work out in a minute. Okay, so now, on the other side, how can I get 12 oxygens? By putting a 12 in front. That'll change this to 12. That also gives me 12 hydrogen plus 2. 12 plus 2 is going to give me 14. Now, I know these are big numbers. On balancing equations, yes, you can have high numbers like 25 or 50, 24. You can always reduce, so don't be afraid to go big. Okay, sodium. This also gives me 12 sodium. So what do I need here? 2 times what will give me 12? A 6. So this gives me 12 sodium. Remember that this 6 not only affects sodium, it also affects the sulfate. So now I have 6 sulfates. Over here I only have 1 sulfate. So 1 times what will give me 6? 6, right? Now is everything equal? Yes. 12, 12, oh wait. 6 times 2 is 12. 12 plus 12 gives me that 24 for the hydrogen. So yes, it's equal. Okay, look at that mess. Okay, now look at this carefully. I have a coefficient of 12, 6, 6, and 12. See, don't be afraid to go big. Okay, let me show you why. Let's go ahead and erase part of this so you can see. If you can reduce, you must reduce. So, if I have a 12, 6, 6, and a 12, what can I reduce by? I can divide everything by 6, right? 12 divided by 6 gives me 2. 6 divided by 6 gives me 1. 6 divided by 6 is 1. 12 divided by 6 is 2. These are my coefficients because I can no longer reduce them. Okay? Very good. Make sure your name is on it. Turn it into Google Class. Good job. For sticking through to the end, put a little heart below your name, and I'll give you bonus points.